So we're given an exponential function in our standard form, and we want to convert it over ae to the kt form. Notice the a is the same in both. So actually we can already fill in b if we want. The initial value is 65. We're not given what the output is, whether it's bacteria, whatever it is that's growing at 23% is 65. The only thing we need to find is k, and to do that, notice the e to the k is equal to 1.23. E to the k equals 1.23. So we have that logarithmic equation, which we'll solve with a natural log, which means k equals ln, because ln is base e, of 1.23 equals k. We could also get this number as a decimal, and because we're going to do something with it, I will for now. But if you want to leave it as ln of 1.23 for this one, that's fine. So we can calculate ln of 1.23. And we see, let's go to 4 decimal places. It's 0.2070. I'm going to throw the 1 on there. So, converting the form, we get that f of t could also be written as 65 e to the ln of 1.23 t. Or, if you put in 0.20701, that would be okay too. We've already got the initial value. The continuous rate. We have 2 forms here. We have this one is more like our annual form, and this is our continuous form, the ln of 1.23. So our continuous rate is going to come from right here. We just need to turn that into a percent. So it's 20.701% is our continuous rate. A little bit lower than what our annual rate is going to be, which makes sense when it's increasing. The annual rate comes from right here. Our growth factor is 1.23. That means our annual rate is 23%. It's an annual rate because t is in years. If t had been in months, this would have been a monthly rate. This still would have been a continuous rate. How long does it take to double? We can use either form, so whichever you're more comfortable with. So we know our function here. We want to see how long it takes to double. Well, this is the initial value, so set it equal to double that. That's one quick way of doing it. So we have 130 equals 65 times 1.23 to the t. We'll solve this exactly, and then I'll throw it in the calculator. When I divide by 65, I'm going to get something that's not a surprise. 130 over 65 is 2. Well, we made that happen because we doubled 65. So you could actually skip that step. Anything that has a 23% annual growth rate is going to take the same amount of time to double. We can rewrite this using logs. So we could do a log base 1.23, but then we'll need to change a base formula. So for this one, I like taking log of both sides. I'm just going to use a natural log. That allows me to pull the t out front. So I get ln of 2 equals t ln of 1.23. And then we'll divide both sides by ln of 1.23. Cancel that out over there. There's our exact answer for t. But we'd like to have the number in years, so let's go ahead and calculate it. So ln of 2 divided by ln of 1.23. And there's about how many years? So about 3.5 years, or 3 years and 6 months.